Hello. Sorry about last week. Sorry, I wanted to give you a heads up, and I forgot to tell you that there's no webinar last week. So sorry about that. Okay. Okay. Today we do a Q&A session with you. So I'm happy to answer your questions, preferably about physics and maths, not so much as about how to scan something, but I can answer these questions as well. So yeah, I have 90 minutes. Ask me anything. You can start. Now I'm going to share my screen, and I will post your questions here if you don't mind. And let me share my screen. Okay. You can ask me about particular problems in the assignment. You can ask, yeah. So go ahead. Or just tell me how you're finding the assignments. You don't have any questions. This is going to be a very short session if you don't come up with questions. Ask me to show you something. Show how to do a question. Give hints. Happy to do that. Hope you can hear me. Could you GIE? What does that mean? Oh, give a hint on for 15 on physics. I certainly can. Well, I think I can. Let me check. So, assignments. So physics and maths. Question 15. Oh, the last one. Imagine that the ring is made of beads. Of beads. So, for example, I'll copy your question. Give a hint on 15 physics. So imagine that your ring is made of individual particles connected by ropes. All right, connected by a rope. And then you can draw the forces acting on each individual particle. You can draw the force here and the force here. So that's a tension force and that's a tension force. And if you add these tension forces, that's your centripetal force. That's your FC. Okay, so you can take a section of the rope and assume that it is a point mass. You'll need to work out the angles, and then this will give you the centripetal force, which is linked to the tension because you would know the angle. Does that help, Alexandra? Alexandra? Okay. All right, going on to the next question. Can you explain the spiral road question and give a similar example? Let's have a look. Spiral road. What is it? What is the spiral road? Which question is this? Sorry. Oh, okay. Problem 5. Car drives constant speed down a spiral driveway, radius r. The road is inclined at an angle to what's the magnitude and direction of the acceleration? Well, I think imagining it helps a lot. So spiral ramp car park. So this thing. That's problem 5. Okay, so yes, so we have a spiral road, and so the radius is r. So we have two types of motion. We have a downhill motion. So we have a vertical movement, and we have circular motion. And if you want to find the total acceleration, you take the acceleration of the circular motion and the acceleration of the vertical motion. So that's your total acceleration. That's what I can say. Okay, so remember when you did projectile motion, they said that the main idea about projectile motion is that the vertical motion is independent of the horizontal motion. So here I can say the vertical motion is independent of the circular motion. Okay, so I hope that makes sense. Okay, I found most of the assignment all right, other than the last couple of questions on the math assignment to do with imaginary numbers. Any help with that's a bit vague. The last question. Last what questions? Like transformations? Like watching videos helps. Well, one way of doing it is replacing z with x plus iy. Right. So if you have, for example, z minus I modulus equals 3. They say it's a circle, but how do we know it's a circle? Well, you can do this. You can say that x is x plus iy minus I equals 3. And we know that the modulus of a complex number is the modulus of z is the square root of the real part plus the imaginary part. So copy that question. It's a bit of a vague question, but it's fine. So just move this down. And so we can find, so this is the imaginary part. imaginary part, and this is the real part. So the modulus is the square root of x squared plus the imaginary part, so y minus 1 squared equals 3. So then we multiply both sides, square both sides, and we get x squared plus y minus 1 squared equals 9. And this is an equation of a circle. This is an equation of a circle of radius 1, and y is 1. So it's like this. Okay. So this is okay, sorry. No, I made a mistake. It's the radius 3. So it's shifted by 1, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So it's a much bigger circle than I have anticipated, but like this. So this is x, this is y, and yeah, and the equation of this is z minus I equals 3. This is the equation of the circle. So I've proved that it is a circle by writing it in Cartesian form. This is one way of doing it. Okay, so in example 6 on the maths assignment, in the math example 6, there's example 4, you meant. Sorry. Example 4. Z2 equals line. Where is? Oh, this one. Yeah, it is an error. So -2. So yes, they forgot the 2. I'll change that. I'll change that. So maths, thank you. Maths assignment 301. So it's example. Thank you for spotting that. And I will change that. Two. Yeah, it's supposed to be like this. Sorry about that. And Yes, I hadn't made any more mistakes. And okay, for question 14 maths, it asks for cubed, sine cubed, but I couldn't find any answer no matter what. Oh yes, that is an error. So I've already amended that. So if you scroll down to the question, it looks like this. So very sorry about that. There's no 3. That is me. I made this error. Unfortunately, it got spotted only a couple of days ago. For maths 12b, if you rearrange for z cubed, you get 3 solutions. However, if you just apply the geometry fraction, 6 for each way is correct. I'm not sure what you mean, Victor, by you apply de Moivre with the fractional power, you get 6. How come? How come you get 6? Cube root of minus 27i has 3 values. And a square of a complex number has only 1 value. Therefore, it can only have 3 values. Right? So let's check our understanding. So let's take an easy one. Cubic root of 1. Cubic root of 1 is, there you can do it like this. So how do you find the cubic root of 1? Well, there are different ways of doing it. I'm going to use this one. So x cubed equals 1. So I'm going to do x cubed minus 1 equals 0. Then I factorize this. I know that x minus 1 is a factor, right? So I factor out x minus 1. And when I use long division to divide x cubed minus 1 by x minus 1, as a matter of fact, I get x squared plus x plus 1. Something I remember from school. Okay. And well, x1 equals 1, and x squared plus x plus a quarter plus 3/4. I'm completing the square here. So x plus 1/2 squared equals minus 3/4. So x equals minus half. So that's x 2 and 3 minus half plus or minus root 3/2. I, of course. So x1, so cubic root of x is equal to 1, or it's minus a half plus root 3/2i, and minus a half minus root 3/2i. So there are 3 possibilities. Now, if I was doing 1 to the power 2/3, it's just all the 3 values squared. So which is 1 squared minus 1/2 plus root 3/2i squared, and minus 1/2 plus √3 over 2i squared. Oh, sorry, minus. And these have only one value. So this is either 1 or, well, whatever that is, and whatever that is. So I don't think you get 6. I can't see how you get 6 using de Moivre's. I think it's question 5. Okay. Find the argument of z. Because z on the denominator. Well, you just divide. I mean, find the argument of z minus 1 over z plus 1. Well, whatever z is. Whatever z is. Well, if you want to find the argument of that, so argument of any of a complex number can be written as arctan y over x. Is that so? Plus, well, plus pi if needed, if necessary. Well, sorry, brain freeze. If you have a complex number and you want the argument of this, that's obviously, yeah, the argument of this is arctan y over x. What if it's here? Well, it's going to be arctan y over x plus pi. Is there a simple formula you can obtain for the argument? Somebody help me here. I'm stuck. Is there a general way to write the argument of a complex number with known? Basically, can you express the argument through the real and imaginary parts of a complex number? Express argument of a complex number. Number expressed in RE and M. Doesn't seem like. Well, okay. If it's the problem I'm having that if the angle is in quadrant 1 and 2, that's correct. But if the angle is in quadrant 3 and 4, then you have to add pi to it. So plus pi sometimes. Anyways, if you have z minus, what was it? Z minus 1, z plus 1. You would do z, so x plus iy plus minus 1 over x plus iy plus 1. And then you would find the complex conjugate. So x plus 1 plus iy. So you need to multiply this by x plus 1 minus iy. So x minus 1 plus iy, and you multiply this by x plus 1 minus iy. Right, so you expand the bottom, and the bottom becomes x plus 1 squared plus y squared, and then this becomes x minus 1 times x plus 1, so that's going to be x squared minus 1 minus, well, let's find the real part first, so plus y squared plus minus iy x minus 1 plus iy x plus 1. And so the real part of z minus 1 over z plus 1 is x squared minus 1 plus y squared over x plus 1 squared plus y squared. And the imaginary part of z minus 1 over z plus 1 can be expressed as yikes, minus y x minus 1. I'm not simplifying it because I'm lazy. X plus 1 over x plus 1 squared plus y squared. And then you find the argument of z minus 1 over z plus 1 can be expressed as arctan of this thing divided by this thing, of arctan of the imaginary part of z minus 1 over z plus 1 divided by the real part. So I hope that helps. Z plus 1. What do you do because you have z in the denominator? So Alex, does that answer your question? When you have z in the denominator, that's what you do. You multiply by oh yeah. You multiply by the conjugate, and that removes the imaginary part from the denominator. I think there's an error with the alternate sign form as well. So what is that? What do you mean by alternate sign form? Which page, Radub? Oh, okay. Pointed out early. Okay. All right. Thanks. Problem. Thank you. In physics problem, should we just take time period as 24 hours? It should be 24 hours. 24 hours is fine, Andre. 24 hours. Besides, yeah, how do you count the day? Because is a day one rotation around the axis, or is a day the time between two middays? I mean, when the sun is in the highest position, because that's different, right? So yeah. So like a solar day, there's a solar day, and there's a I think it's called stellar day, when the stars. So are you comparing? Are you measuring the time it takes the sun to go around the Earth? Well, motion is relative, of course. The sun goes around the Earth. Why not? It doesn't take. It takes a different time because the Earth moves on the orbit. So yeah, 24 hours is more than insufficient accuracy. The Helsinki pointed out again. Physics problem. Where's the center of rotation? Serena. Physics problem 6. Oh, that's maths. It's here. So this is the axis of rotation. This is the axis of rotation. So it's going around this axis. So if you look from the top, if your eye is up here, if you look from here, you will see the axis of rotation, and you will see two masses, mass M1 and mass M2, moving in circles. So mass 1 moves in a circle of smaller radius, and mass M2 moves in a circle of bigger radius. So this is the center of rotation, and they go, M2 goes this way, and M1 goes this way. Does that make sense, Serena? It is horizontal, yes. It is horizontal rotation. No, it's not vertical rotation. Oh, I need to specify this. In a horizontal plane. Sorry, I'll amend this right away so that we don't have this problem next. Yeah. So what am I searching for? Horizontal bar. Horizontal bar. Master connected by are set into rotation in a horizontal plane. Okay. I've changed that. Okay. Well, I think I reached the end of the questions. Anything else? It's only been 33 minutes. You can ask me other questions. Like with the year 10 and 11 and 12, I had to stop because there were so many questions. I did more than an hour and a half. So is the year 13 assignment so easy that no one has any questions? Okay. Maths problem 9, how would you start? Year 13 whiteboards. What do you mean share the whiteboards for year 13 too? Like, yes, I do share the whiteboards by all means. Are you asking about the the whiteboard from last year. Yeah, by the way, just a quick note, you do have webinars. If you go to webinars on our website and you click all year 13 webinars, you can access the recordings from last year. So we have circular motion, complex numbers, circular motion, complex numbers, circular motion, Q&A. Oh, I did Q&A last year as well. Then we had differentiation and gravity, gravity in orbits, differentiation, Euclidean, etc. So all the topics that we're doing will be covered in this. Oh, did I not do webinar 02? That's strange. Oh, I meant that. So yeah. And we had a whiteboard last year as well. You can access that. COMPOS Year 13 webinars. This is from last year. So the average last year. So the question, what is average last year? So I don't know the average last year, but we accepted anyone above 50% average. We accepted last year. Accepted anyone above 50% average, but a minimum 35% for each subject. So you couldn't do 80% in maths and 20% in physics. Right, so there was a question. Math problem 9, how would you start? Let's have a look. Math problem 9. Well, we know this. You just substitute for a math problem 9. So you substitute. So let me. It's actually quite straightforward. So you have sub your values into here. Okay, like with year 12, would it be possible to tell us the average last year? We did that. How many applicants were placed for year 13 this year? Quite a few, more than last year. We're very popular with year 13 this year. And it looks like it's going to be 3 candidates per place this year. Oh, no, sorry. Yes, looks like it's going to be 3. Last year it was 2 candidates per place. Well, 1.9, and this year is about 3. So yeah, But we will try to accommodate everyone who can. We might be able to have more places. We are actively searching opportunity to get more tutors and get more capacity in terms of tutorials to get more students in. So, yeah. Could you email me with questions? You can try, but I have to say I'm quite busy with lots of things. But you can email me. If I don't reply, that means I'm busy. But if yeah, why don't you use computer modern font for the physics assignment? Computer. I have never heard of computer modern font. Computer modern font. I don't know. Computer modern. My favorite font is Ubuntu. Ubuntu. That's just my personal favorite. I just like it. But this is not. Yeah, I don't know, Edith, why we're not using computer modern font. I'm not actually sure which font we're using. Yeah, we might consider later on changing the font. Anything else? Don't worry, asking easy questions if you're not sure about something. I would be happy to hear why we should use the computer modern font. We might use it. So I don't know why we should use it. So yeah. Okay, then we'll finish here because do all circular motion question types have similar one on the previous webinars? Do all circular motion question types have similar ones in the previous webinars too? Yes, we oh. Okay. Oh, for the physics assignment. Not sure what went wrong. I'll check. I'll check. Wait, last year it was 50% of questions that were right that you got a place on average for 2 subjects. Yeah, so if you got 50% in physics, 50% in maths, you got in. Yeah, you got in. Or you got 40% physics, 60 maths. It yes, I can't comment on that. I don't know. I don't know until we get the marking in, and this will happen on Sunday. It depends on how many papers we actually get. I'm expecting to get 300 year 13 papers in. And out of 300 papers, we will be selecting about 120 students. You will be told if you get a place at approximately 1st of November. Maybe earlier, but by the 1st of November, we should have everyone in. Okay. We are searching for opportunities to add more students. So yeah. Okay. It's an accelerated curriculum, as you said. We finished before February. It's not an accelerated curriculum. It's a reduced curriculum, I'd say. We finish mid-February. We finish February half term. And the second assignment will be set next week, most likely. But you will know whether you've got a place or not. So we give you 3. I think we give you 4 weeks for that. So let me check. We will publish the second assignment next week, and the deadline would be the 12th of November. So we give you a month. We give you a month to do it, but well, it will take us some time to mark your first assignment, and you'll have about 2 weeks to do the second assignment after you've got information. We confirmed your place. Basically, that's what I'm saying. But 4 weeks overall. Okay. Right. Yes, I'll publish the second assignment as soon as it is ready. It will be on the website and in Google Classroom. And then 1st of November, you get a place, and then you have 2 weeks to do it with a tutor. All right, then go look through the previous webinars. That's very useful. And I've done lots of questions. I hope that helps. And so I'll see you next week. Enjoy. Are you more likely to get in if you completed last year? If you've if you completed COMPOS last year, you automatically get a place. All right. Okay. See you. Oh, but you do need to register. If you haven't registered, well, all of you have registered because obviously you are here. But yes. Okay. See you.